In the vast expanse of space, a breathtaking spectacle unfolds. A nebula, a cosmic cloud of gas and dust, stretches across trillions of kilometers. Shimmering with iridescent hues, it's a stellar nursery, a place where stars are born and planetary systems take shape. This is where our story begins, the story of Earth's birth. Imagine a time before our sun, before our planet, before life itself. The nebula that would birth our solar system was a chaotic, swirling mass. Gravity, the architect of the cosmos, worked tirelessly, pulling gas and dust together. Over eons, this cosmic dance transformed the nebula. It set the stage for the dramatic birth of our planet, a tiny blue marble in the grand cosmic theater. Within this swirling cloud, a dense region began to collapse under its own gravity. As more and more material was pulled inwards, temperatures soared, and a protostar ignited at the heart of the nebula. This was the birth of our sun, a fiery ball of plasma that would become the anchor of our solar system. Around this newborn star, the remaining gas and dust continued to swirl and collide. Over millions of years, these particles coalesced, forming larger and larger clumps. This process, known as accretion, marked the beginning of Earth's formation. As our sun blazed to life, its powerful solar wind pushed outward, sweeping away the lighter elements like hydrogen and helium. The heavier elements, forged in the hearts of long-dead stars, remained closer to the sun. These elements, the building blocks of planets, would play a crucial role in Earth's destiny. Within the swirling disk of dust and gas, small rocky bodies called planetesimals began to form. These planetesimals, drawn together by gravity, collided and merged in a chaotic ballet of cosmic proportions. Over millions of years, these collisions grew larger and more violent, eventually forming protoplanets, the precursors to the planets we know today. Earth, still in its infancy, was a hot, molten world bombarded by a relentless barrage of asteroids and comets. This period, known as the Late Heavy Bombardment, played a pivotal role in shaping our planet's future. The impacts delivered water, essential for life, and other volatile compounds that would later contribute to Earth's atmosphere and oceans. As Earth cooled and solidified, its molten surface hardened, forming the first crust. As the solar system matured, a delicate gravitational dance emerged between the sun and its planets. Each planet, influenced by the sun's immense gravity and the gravitational pull of its neighbors, settled into its own unique orbit. Earth, positioned at just the right distance from the sun, found itself in the habitable zone, a region where temperatures are ideal for liquid water to exist on a planet's surface. This Goldilocks zone, not too hot or too cold, would prove crucial for the emergence of life on Earth. While the inner planets, Mercury and Venus, were too hot and the outer planets too cold, Earth's position was perfect. It allowed for the formation of vast oceans, the cradle of life. The early Earth was a far cry from the tranquil blue planet we know today. Volcanoes erupted across the surface, spewing molten lava and gases into the atmosphere. The atmosphere, thick with carbon dioxide and other greenhouse gases, trapped heat from the sun, creating a scorching hot environment. Yet amidst this chaos, the stage was set for the most remarkable event in Earth's history, the origin of life. Imagine Earth, billions of years ago. The sky is a hazy orange, the air thick with volcanic gases. Lightning crackles across the sky, and molten lava flows across the surface. This was Earth's early environment, a hostile and unforgiving place. Yet in this primordial soup of chemicals and energy, life found a way to emerge. The exact details of how life arose from non-living matter remain a mystery, but scientists believe that simple organic molecules, the building blocks of life, formed in the early Earth's oceans. These molecules, through a process called abiogenesis, self-assembled into more complex structures, eventually leading to the first single-celled organisms. These early life forms, known as prokaryotes, were incredibly simple. They lacked a nucleus and other membrane-bound organelles found in more complex cells. But they possessed the remarkable ability to replicate themselves, passing on their genetic information to their offspring. This marked a pivotal moment in Earth's history, the beginning of life's long and remarkable journey. Life, once confined to the oceans, began to diversify and evolve. Photosynthesis, the process by which organisms convert sunlight into energy, emerged, releasing oxygen into the atmosphere. This oxygen, toxic to many early life forms, triggered a dramatic shift in Earth's environment. As oxygen levels rose, the atmosphere gradually transformed, paving the way for the evolution of more complex life forms. The ozone layer, a protective shield in the upper atmosphere, formed, absorbing harmful ultraviolet radiation from the sun. This allowed life to venture out of the oceans and onto land, opening up new habitats and opportunities for diversification. The emergence of multicellular life was another major milestone in Earth's history. Around 600 million years ago, during the Ediacaran period, the first multicellular organisms appeared in the fossil record. These strange and enigmatic creatures, unlike anything alive today, represent a pivotal step in the evolution of complex life. Over millions of years, life on Earth continued to evolve and diversify, driven by the forces of natural selection. From the Cambrian explosion, a period of rapid diversification of life forms, to the reign of the dinosaurs, Earth has witnessed an incredible array of life forms, each adapted to its own unique ecological niche. The evolution of plants transformed the planet's surface, creating vast forests and grasslands that provided habitats and food sources for a myriad of creatures. Animals evolved to take advantage of these new environments, developing complex relationships with each other and their surroundings. The extinction of the dinosaurs 66 million years ago marked the end of an era. It also opened up new opportunities for mammals, who diversified and evolved to fill the ecological voids left behind. Among these mammals were our own ancestors, small, shrew-like creatures who would eventually evolve into modern humans. Humans, relative newcomers on the evolutionary timeline, have had an outsized impact on the planet. Our capacity for abstract thought, language, and tool use has allowed us to reshape the world in ways no other species has before. We've built cities, cultivated crops, and harnessed the power of fossil fuels, transforming Earth's landscapes and altering its climate. While human ingenuity has led to incredible advancements in technology, medicine, and our understanding of the universe, it has also come at a cost. Our activities have led to deforestation, pollution, and climate change, pushing Earth's systems to their limits. The consequences of our actions are becoming increasingly apparent, from rising sea levels to more frequent and severe weather events. The challenges we face are significant, but they are not insurmountable. We have the knowledge, the tools, and the capacity to change course. The future of our planet depends on our ability to recognize our interconnectedness with nature and to act responsibly as stewards of Earth's resources. Earth is a complex and interconnected system, with a delicate balance of physical, chemical, and biological processes that have sustained life for billions of years. Our actions have disrupted this balance, leading to unintended consequences that threaten the very systems we depend on. Climate change, driven by the burning of fossil fuels, is one of the most pressing challenges of our time. The increase in greenhouse gases in the atmosphere is trapping heat, leading to rising global temperatures, melting glaciers, and rising sea levels. These changes threaten coastal communities, disrupt ecosystems, and exacerbate extreme weather events. Pollution, another consequence of human activity, is contaminating our air, water, and soil. From plastic waste accumulating in the oceans to toxic chemicals entering our food chain, pollution is harming wildlife, damaging ecosystems, and threatening human health. We must reduce our reliance on fossil fuels, transition to cleaner sources of energy, and adopt sustainable practices that minimize our impact on the environment. As we gaze upon the vastness of space, we are reminded of our place in the cosmos. Earth, our pale blue dot, is a precious oasis of life in the vast cosmic desert. It is our only home, and it is our responsibility to protect it. We must embrace a future where humans and nature coexist in harmony, where we live within Earth's planetary boundaries and ensure the well-being of all living things. This requires a fundamental shift in our values and priorities, a recognition that our actions have consequences that extend far beyond our immediate surroundings. We must act with urgency and determination, guided by science and compassion. Let us work together to create a sustainable and equitable future for all, ensuring that Earth remains a vibrant and thriving planet for generations to come. Our cosmic duty is clear: to cherish and protect our pale blue dot, the only home we've ever known.